All right, welcome to science lesson today. So we are finishing off our kinetic molecular theory unit on expansion and temperature. So with that being the case, just a heads up, your next lesson is going to end up being, what is it called? An open, blah, blah, blah. It's going to be an open book test. Anyways, so make sure you're letting me know if there's some parts of the kinetic molecular, I can talk. Kinetic molecular theory. I would like to see you guys say that like 10 times really fast. See how it goes. Anyways, if you're not understanding any parts of the lessons that we've done lately or this lesson, let me know. Like I said, the test will be open book, so you are allowed to look at the notes and videos or look up stuff on Google. That's fine. But again, if something's not making sense after this lesson, just let me know. That way we can make sure you are good to go for the test. All right, now let us begin. So this is actually, I found a pretty fun unit here. Keep in mind for me, this is actually my first year doing grade 8 science. And so I'm getting a chance to revisit all this material. And this, like I said, this one was a fun one. So expansion and contraction of materials. So with this one here, as you can see, that let's say if you ever had some extreme temperatures, especially if it's gotten really hot outside, let's say if you had a tin roofed house, you would actually hear those roof panels starting to groan and creak. And that has to do with expansion. So what will happen is that not all materials, but some materials will become slightly larger when they're heated, and that means that they're expanding. And then there's going to be other ones, they can also shrink slightly when they're cooled, and that's when they're contracting. And so that means that for that tin roof example, that the metal roof panels, that they're expanding and contracting as the outside temperature changes. And so then what happens, those panels are scraping against each other and against the nails that keep them in place. That's why you're hearing those creaky sounds. It's just simply because it's because it's expanding. Let's see how I can get through this lesson with talking here. And I'm not sure if you ever had it where at home, let's say, depends on the construction of your house, depends on how old it is and all that kind of stuff. But I don't know about you, but for me, with my place, I noticed that during the winter, winter and summer, it's definitely different with being able to open and close my outside door. I find, especially for locking it, I find that different times of the year, I'm having to really try to get it to close properly so I can lock it. Other times it's easier, and it depends on the temperature. Okay, now what we're going to do is look a little bit more into expansion and contraction of materials. And so when an item is being heated, then those particles are going to move faster, so they push apart further. So think about, let's say, a liquid becoming a gas. They are those particles that are like, let's say if you had a pot of water on the stovetop, then what would happen are those particles in the water are going to be moving a lot faster as they're getting heated, and they're pushing further apart, because with a gas, we have it where the particles are much further apart from each other compared to a liquid or a solid. And so they're pushing further apart when they're being heated. And then when an item is being cooled, that is when the particles are going to be moving slower and they move closer together. All right, now we're going to keep going here. So some solids are going to expand more than others. We will look at that more further in this lesson. So it's people who, let's say, create bridges and things along those lines, they have to really keep in mind what's going to happen as far as the physics of what will happen to these materials underneath different temperatures. Because if they don't plan accordingly, things like a bridge could completely fall apart underneath more, not so much extreme weather variations, but when you think about it, down here or I should say up here in Canada, we have winter, we have summer, we have definitely quite the significant temperature difference between winter and summer. And so that takes a toll on items like roads and sidewalks and bridges. So with that being the case, they have to find ways to be able to work with those materials that are going to be expanding as the temperature gets warmer outside. And so they need to find ways to allow for that. And we're going to explore what some of those ways are. So let's say we have a concrete path. Think about a sidewalk. Now, if they never made room for expansion, then you would see a lot more cracked sidewalks. Just because they didn't make allowance for that concrete to start expanding as the sun got hotter outside. And so, whereas if you see little gaps, well, actually we're going to look more into that, but here, so the picture on the right here, they didn't allow for the expansion of the concrete blocks. And so a lot of times when you see these cracked sidewalks, a lot of it, like some of it, yes, is just going to be natural toll because of its age and how long it's been around there. But also they might not have had it where they made allowance for the concrete to expand, and so they're going to end up having it where it starts to crack. Whereas here, if they have it where they make an allowance for that concrete to expand a little bit, then it's going to not be rubbing up against each other when it expands, and so it's less likely to crack. It's going to stay in better shape. So going to the bridge example, that what happens is they have to allow for the contraction and expansion of the materials. Otherwise, again, you'd end up having a bridge that's going to fall apart. That's not very safe. And just think about the bridge here by Lake Okanagan. If we didn't have good materials, and not just good materials to build the bridge, but good materials to allow for the expansion and contraction of that bridge, if we didn't allow for that, we wouldn't be able to be using that bridge very long. With enough time and enough exposure to the elements outside, it would become useless because it would be unstable to drive on. So thankfully, when you get engineers who are aware of that, you can make allowances for that. And that's why you'll see things like this that are going to end up having it where it's like interlocking teeth, basically. And so what it does is it allows the bridge to expand and contract while those teeth slide past each other. So they're not having it where the concrete is smushing up against each other and having it where it's crumbling. It's now with these teeth here, it allows it to be able to expand, contract, to still stay together enough that we can safely drive on it, but have it where it's not going to cause damage to the bridge when it's expanding and contracting. Now, you get a chance to be able to watch a video of this. I will be including the link to that. And something to think about as well is that with bridges, if you're in like a tropical country or a place where the temperature stays consistent pretty much all the time, then they don't have as much need for things like expansion joints because the temperatures stay roughly the same. So it's not as critical for them to be able to make sure that they are allowing for that expansion and contraction, because it's not going to happen as much in those situations. Okay, and so again, we have it where we're looking at a road that has pretty extensive cracking going on here, and that's because maybe they didn't use the right expansion joints. Also, quite frankly, it could also just simply be quite old. Like, you will have to do maintenance on all these different kinds of materials because they still are exposed to a lot of wear and tear, as well as just the simple fact of being exposed to the elements year round. And so it's not always an indication that it has completely failed as far as the expansion joint. Sometimes it's just a simple matter of, yeah, it's old. It's old, so it needs to be updated. Okay. And so here, obviously, you can see that if they don't have proper expansion joints put in place, look at this. Look how awful that is. It's much more likely to pull apart or push together and fail. All right, we're going to move on to that in a moment here. What I'm going to do is I will have it where I'm going to stop this video and we're going to go into our Google Docs into the next video and start having it where we are filling out the notes. I will see you back for part 2.